As Piotr Szatkowski is ill, Michał Kisilewicz has spontaneously stepped in to give the presentation in his place, which we are happy about. What will it be about? He presents the latest developments in the field of biocomposites. The combination of biodegradable plastics and natural fibers opens up new applications and opportunities for Poland and Europe. And here we go. Please listen to Michał Kisilewicz from the Polish Composite Technology Cluster with a lecture on the topic Development of Sustainable Biocomposites and Recycling in the Polish Cluster of Composite Technologies. Review of current research and threats. A very warm welcome to you, Michał Kisilewicz.
Thank you. So I want to show you what we do in Polish cluster of composite technologies, and that will be division of biodegradable materials and recyclable. So we show what we do, and as on the start, we are a group of the people as a think tank. So we think about new materials and possibilities to use it. So we show you in the next slides what we can show. So because we work with also non-disclosure agreements for the companies. So on the start, as you know, there is many composites, and we choose this very special composite for us, so biodegradable. Why we choose these biodegradable materials? Because we think that will be the clue, the solution of the big cycle of life. Yeah? So if we produce something, the thing also sometimes lose the properties with the time, and so they are dead, and later we throw them, and after that, if they are biodegradable, they can make again. So as for example, plants, or can be used for animals, so there will be more useful. So what we do normally as a think tank, so we think how to make better materials, but I think the most important is that we're looking for our environment. So we're looking for sustainable solutions in Poland, especially in South Poland, because we are placed there, so we know the most this ecosystem, because we looking for the biodegradable materials which are made in Poland. We looking for additives which are very not far from us, and so we think about markets also, but on the beginning I start. So we think about concepts. The most important is for us that the solutions should be profitable, because we make composites from different materials, but if they aren't profitable, so the implementation later is impossible. So we have some goals which we try to develop and to achieve, and this will be I think the most important, start to cooperation with the companies, because when I start work with biodegradable materials, nobody knows how to use it. and I go to companies. We want to make a sample, for example, injected object like a cup or a extruded string, fiber or something else, and nobody knows how to use it in the companies. So we try to also connect to companies and show them how to produce these materials, and that is maybe more difficult because everyone used polyolefins, and polyolefins are very simple to produce, as you know. So as a cluster, a think tank, so we try to also think how to exchange our knowledge and transfer knowledge to the Poland, how to produce better materials, and maybe also find new connections, new materials, new additives, which we can use in Poland or also send to different countries. So as a think tank, so we have many people with different skills. So for example, I have experience in manufacturing and processing of biocomposites. My colleague, which is absent, is very scientific, so he think about new materials. But we have also many people who produce every day biodegradable materials, and they found some problems with them and some solutions. And that's, I think, what's the most important. So why we choose biodegradable materials? Because we want to maybe more difficult materials, because we can choose in composite some parts of biodegradable, so we can choose biodegradable resin, for example PLA, PBS, and compact to some glass fibers. Or different side, we can choose, for example, polyethylene with some wood chips, but that will be not biodegradable. We choose the most advanced material, but the most difficult. We know that. And so one day we think how to, what we have in the Poland, in the west, south Poland, what we can combine. And we think that we have many ways to produce starch, for example, very happy potatoes, and also very fine grade of wool. So if we combine this, we may prepare fine biodegradable composite. So we increase the properties of resin, and we use wool. When we choose wool, because we start to when we looking for the additives for materials, we find that the wool in Poland, in this area, is treated as a waste. So it's not used to produce clothes, but they are waste because the lignin and other processing is very, very cost, and they utilize this. So, as I told you, there is many polymers, so we choose and try combine different types with also with different grades, with different types. Sometimes, you know that there's additives additive increase of some mechanical properties or different properties when you combine different materials. And when we choose this wool, we find one problem, because if we use natural fibers from the plant, that's natural, yeah? That's obvious. But if we use fur, wool, or something else from the animals, that's something the people sometimes don't want to use this, because this is in psychology, yeah? So that's very different, but probably that is a way to introduce or learn people that we can use these materials, maybe not in the cap, but in different kind of materials. So that's very, very interesting that the psychology is also very important in composites. So why wool also? Because there is a very good temperature isolator, because the thousands of years of evolution. So that will be the best material, and we can find this and use it. Of course, there is many problems with this processing, so we are solving it, because the structure of the wool is complex. So now the question is, we should use the wool as a fiber, or we should decompose this fiber to the finer structures and mix this. So we choose this and we try it. Of course, on the beginning, we need to make a low TRL project, so that will be this. And so we choose wool, and we try introducing different levels of wool and different way of introduction. So we see that there is not, the flow is a little bit not the best, but that's only beginning. So we will improve this. So that the structure of the material. So because sometimes we need to also check of structure. I have in one company very problematic way to achieve exactly fine microstructure, because the softness of the skin should be achieved. And that will be another samples made a little bit different way, and we check how the wool will be, how the processing, how the drying of wool will have impact on the samples. So as you see, we need to improve a little bit drying, but that will be a problem with lignin. Not lignin, but lanolin. So the oils on the wool. So that's the next problem to solve. So we check the material about, because we are looking for the insulation material, so we check this, how that will be change temperature with the time. So there is impact and there is improvement, but we need to improve a little bit amount of the wool, and maybe also we should introduce the porosity to the samples. A very simple way to check degradation. So because we want to degrade. I personally, I don't like this norm because I think 10% of residue, it's not quite okay because we may add different materials, for example, stone to polymers, biodegradable, and it will be stone after degradation. So I think we should maybe talk about this separately, about this degradation norm. In America is 40%, and the time, which also is very important in our way. And I think if something will be degraded 2 years, isn't a problem, because the wood is degradable a few years. So I think that's my personal opinion, but we check for the norms. So we try to improve this and connect to the norm which are in Europe. So we see that the composition occurs. We saw that very in a different way. So we saw that the wool also, I'm not sure how to say, but that the small animals don't eat it because they are wool and they don't like it. So that will be very difficult. And that is a topic which I am involved more. So controlled release fertilizers. We have also big companies which produce fertilizers, and we talk with them and that there is the way to improve the fertilizer function. So how we improve this function? For example, we can move and make longer releasing fertilizer, for example, nitrogen, which is very difficult because nitrogen release very quickly. And when it release very quickly, we have problem in the rivers because the algae is starting to grow. So that will be very problematic. And this solving may reduce this nitrogen releasing, and we may use less fertilizers. But also there is difficult because how to achieve the biodegradable encapsulation for this material. So we think about the wool. Wool have possibility to release nitrogen. So if we made a encapsulation with wool, that wool be as a motorway for the nitrogen or other substances. We make some samples, and we see that it works. So the encapsulation and longer releasing of nitrogen makes better growth, and if there will be longer releasing, the roots will be stronger, because if you use too much nitrogen, so you may kill roots and the plant will die. And more information. So we check this in ultraviolet, which the material, which the substances which are ultraviolet seen. So we see that the fertilizers are working, so there is a very slow releasing of materials. So the way how we do it, and we do it that's sample, so MVP only. In the industrial scale will be different way, but I think on MVP it's okay. And we see that the greenness of the plants is better, and the plants are bigger. So we see the released materials on the micro elements on the surface of the material. So that this kind of work is connected to the more sustainable energy and consumption. So we want to make better plants, so with better time to release. And maybe the last project, so that will be also biodegradable products, but we use the colorants which are waste, so waste which can be used as in the contact with food. So that will be very interesting, and maybe I told us on the break. So we have success, and we add also possibility to use it in the 100 Celsius degree. So I think that will be end, and as you see, we are think tank, and we think about new things or from different ways. So we try to make it more sustainable. So thank you.
Thank you very much for your great lecture, Michał Kisielewicz from the Polish Cluster of Composite Technologies. Here is also a nice power plot for you. And so thank you very much. And yeah, does anyone have a question? We have time for one question.
Is there? Oh yeah, there's Mr. Hessner in the back. Yes.
Thank you for the interesting presentation. Sebastian Hessner, Evonik. I have a question regarding the thermal stability of the sheep wool. When you process it with PLA, is there a certain degradation, or does it occur in Malodor?
Yes, that's why we think how to process this, and as you see, we don't use normal extruders, because it may degradable. It may degrade. Yeah. Temperature degradation may occur. So we choose melting on the flat surface. So that's the difficult. But if you process that very quickly, it may be possible. So we try to redesign our extruders and to add this material at the end of after melting, for example. So it's more difficult, but it's possible also.
Thank you very much.